In this lesson, we'll learn how to solve application problems involving work. In physics, the concept of work refers to the transfer of energy from one object to another that causes the object to move a certain distance. Therefore, work is done by a force whenever the force moves an object. The simplest formula for work is W is equal to the force times the distance, where F is the magnitude of the force and D is the distance traveled. However, this formula is true only when the force is applied parallel to the line of motion. Suppose that the constant force applied to an object is not parallel to the line of motion, but instead is applied to the object at an angle theta between the object and the horizontal. In this situation, let F represent the force of an object with a direction angle theta relative to the line of motion. If the object moves from a point P to a point Q, then let D represent the distance between P and Q. The force F in the direction of D is the vector projection of F onto D. So with that being said, if we take a look at the formula W is equal to FD, this gets modified in the sense that we replace F with the vector projection of F onto D, specifically its magnitude. And that can be found using the vector projection formula, where you find the components and then from there find the magnitude. Or what you can do is use the magnitude of the vector F, which I'll represent as F sub 1 in these double absolutes to represent magnitude, times cosine theta. The reason why that works is because if we want this vector, that's adjacent relative to this angle. And only cosine compares adjacent to hypotenuse. Hypotenuse we already have. We can find the magnitude of this vector if it's given. That then gets multiplied to the distance d. So the magnitude of PQ, which we'll call d. And whenever you write down vectors by hand, you make sure you put these arrows at the top. If that's confusing to you, let's take a look at an example. In this example, a horse is pulling a plow with a force of 400 pounds. So let's draw a horse. It's pulling a plow using a harness, and the angle that it makes with the ground is 20 degrees. So that right there is 20 degrees. And the force is going in this direction, and it's 400 pounds. Of force. It drags this plow 50 feet. So the distance from here to here, let's say, is 50 feet. What we will do is find the vector projection of this vector, namely the vector projection of this force vector, which I'll call F, onto the horizontal plane, and we can name that anything we like. Let's call it D. We need the magnitude of this vector, and that can be found, given that this is 20 degrees. We take cosine of 20 degrees, and we multiply it to the magnitude of this vector, which we are told is 400. So this right here represents the magnitude of the projection vector of F onto D. Notice I add these double absolutes to signify that this is the magnitude. And this gets multiplied to the distance in which this horse moves the plow, which is 50. Therefore, by multiplying these out, 400 times cosine, make sure that your calculator is in degrees, times 50, we get the total work as 18,793. 85 foot-pounds. And there you have it. That is how to solve applications involving work.